Hello, Math Wizards! Welcome to a lesson episode of Just Math PH. So today, we will learn about quadratic functions. So ano nga ba ang kaibahan nito sa quadratic equation? At we will also learn paano mo malalaman if ito ay isang quadratic function. Halimbawa, meron kang table of values or meron kang equation or graph, how would you know if it is an example of a quadratic function or hindi siya quadratic function? Bago natin pag-aralan ang quadratic functions, we have to review first some of the important topics na magagamit natin in learning about quadratic functions. At ito ay ang rectangular coordinate system. So we have here the rectangular coordinate system and then evaluating equations. So we have here a table. What we will do with the table of values, we will complete this table of values where we will substitute the value of x here in our equation and then we will solve for a y. After that, we will use the ordered pair that we got here and then we will plot it in our Cartesian coordinate system. So we have here our equation y equals x plus 5. So we have here an example. If x is -1, so -1 plus 5, that is +4. How about if x is -2? So if x is -2, then y is equal to -2 plus 5. So the answer is +3. So here this is 3. Now if let's say if x is 0, you will just replace our x here with 0. So that is 0 plus 5. Our y is 5. Okay? So, if we will just continue the process, kung ipapatuloy natin yan, if x is 1 naman, so 1 plus 5, y is 6. If x natin ay 2, so 2 plus 5, that is 7. If x is 3, so 3 plus 5, that is 8. We have here the rectangular coordinate system. So let's review some of the parts of it. So this line here is what we call the x-axis. Ito yung line na nakahiga. At saka this line here is the vertical line, or we call it the y-axis. So on the right side of the x-axis are positive, on the left side of the x-axis are negative. Likewise with the y-axis, above part of it are positive values, while below of it are the negative values. At dito sa gitna, this is our origin with the point 0, 0. Now, we have here the table of values and we can write it in an ordered form. So, our ordered pair is written of the form xy, where x is what we call the abscissa, or ito yung mga values na natin dito sa taas. And then the y, these are the values na corresponding values when we substituted the value of x. And the value was the resulting y. So remember that the x values or the abscissas can only be found on the horizontal line or the x-axis. So, ibig sabihin, titingin ka muna dito, tsaka ka tumingin sa y-axis. Kasi, second coordinate natin yung y-axis. Yung first coordinate natin is the x-axis. So, let's list the ordered pairs na nakuha natin sa ating table of values. Okay, so we have -1 and +4. Then we have -2 and +3. Next, we have 0 and 5. Then we have 1 and 6. We also have 2 and 7. And 3 and 8. So we have 1, 2, 3, 4, 5, 6 points na ipaplat sa ating Cartesian plane. So let's start. This is our x again, and this is our y. So x can be found on the x-axis. So dito muna tayo tumingin. So we have -1. So -1 is on the left side. This is our -1 and +4. So here is our +4. So yung intersection ni -1 at saka ni +4 is the point -1 and 4. Next, let's plot -2 and 3. -2. So -2 yung x. So ito siya, -1, -2, and +3. So 1, 2, 3. So this is our point -2, +3. Next is 0, 5. So 0 yung x. So ito siya. Then 5. 1, 2, 3, 4, 5. So this is 0, 5. And next we have 1 and 6. 1 and 6, yung x natin is 1. So here's the 1, then 1, 2, 3, 4, 5, 6. So nasa taas kasi positive yung 6. So this is 1 and 6. Next is we have 2 and 7. So 2 and 7. So here's our +2. Then 1, 2, 3, 4, 5, 6, 7. So this is our 2, 7. And last, we have 3, 8. So here's our 3. Then 1, 2, 3, 4, 5, 6, 7, 8. So this is our 3, 8. 3, 8. So notice the order of our points. It forms a line. So connecting them, it will look like this. Okay. So we can put an arrow. So the graph is a line because this equation is an example of a linear function. So it's a function because we have the y as our dependent variable. So basically the graph of a linear function is a line. That's why we have here the line graph. So we are done with the review. Now let's define what are quadratic functions. So the word quadratic comes from the Latin word quadratus, which means to make square. Quadratic equations and quadratic functions are almost the same in terms of the rule in their independent variable or the x. So remember, this is our quadratic equation. Ax squared plus bx plus c equals 0. While the quadratic function is y equals ax squared plus bx plus c. So this side here, ax squared plus bx plus c, is the same with the right side of our quadratic function. So the rules of the x is the same with the quadratic equation and quadratic function, which is x is our independent variable. Now here in the quadratic equation, we don't have the value of y, while in the quadratic function, the 0 here becomes y. So it means that y is dependent to our variable x. So again, this standard form of the quadratic function is y equals ax squared plus bx plus c. So this one is still considered as an equation. It is just that a quadratic function equation. So in both terms, the quadratic equation and the quadratic function, the a, b, and c are real numbers, and we still follow that a is not equal to 0. So again, the standard form of a quadratic function is of the form y equals ax squared plus bx plus c. So since this is a function, the y here can also be replaced as f of x, meaning it is read as the function of x, which is equal to a x squared plus bx plus c. So basically, y and f of x are the same. So sometimes we can replace f here as g of x, okay, or it can also be replaced as h of x. So depends on the name of our function. So y or h of x or f of x are just the same, so don't get confused with that. It is just the name of our function. So on the right side of our equation, we have here the ax squared plus bx plus c. So always observe that it should be in arranged form, and on the left side is the value of y. So we cannot simplify the equation anymore. So suppose you have here y equals 2x squared plus 2, and you want to simplify the right side by dividing it by 2. You want to divide it by 2. That's not anymore possible because remember, y is also a variable. So basically, if we do equality, you have also to divide the left side by 2, and that becomes y over 2, and it makes our equation complicated. So we can't do that anymore because this is not the same as the quadratic equation. So since this is a quadratic function, so remember in the quadratic equation, the value of a should always be positive. But since this is a quadratic function, a can sometimes be negative, and it tells us whether the graph of a function opens upward or if it opens downward. So it has meaning on it. We have here some examples of quadratic functions with a, b, and c values. So first example, y is equal to 3x squared plus 4x plus 7. So our a is 3, our b is positive 4, and our c is 7. Now for number 2, we have y equals x squared minus 5x. So we know that there is an invisible 1 here. So our a there is positive 1, and b should be negative 5. So since c is 0, so it means c here is not visible. It means c here is 0. So again, y is the same as f of x. So our a is negative 6, our b is 0, and our c is positive 8. For number 4, our a is positive 1. And notice our b here and c are both 0. Identify whether the equation is a quadratic function or not. So for the first example, we have y is equal to 2x minus 10. So obviously that is not a quadratic function because remember that the highest exponent of our function should be 2. So the highest exponent of our x here is 1. So this is not a quadratic function, but this is actually an example of a linear function. So number 2, again, this is not a quadratic function. So notice that the highest exponent of our variable x here is 3. So it's not a quadratic function. Number 3, f of x is equal to 5x minus x squared. So if you write that in the standard form, so we have to write first negative x squared. So here it is. Then follow plus 5x. So our a here obviously is -1 and our b is 5. So it is an example of a quadratic function. And last example, y equals x minus 2 times x plus 4. So that's a quadratic function because if we distribute x minus 2 to x plus 4, so if we distribute that, so x minus 2 times x plus 4, we have -8, positive 4x, and -2x, and positive x squared. So this is -8, positive 2x, and copy x squared. So this is y is equal to, that is y is equal to x squared plus 2x minus 8. So that is an example of a quadratic function. So earlier we've known how to identify if the equation is quadratic or not. So how about if we are given table of values like this? How do we identify if this table of values, so suppose the equations are not given, so how would you identify if the given table of values represents a quadratic function? So I already completed the table of values here. So what we did here, we just replace x with -3, then you multiply it by 2, then add by 1. So we have the following values for each corresponding values for x. So the same here with g of x. So these are the values of y as we substituted the values of x. Now, how do we know if this table, suppose the equation are not given, suppose we don't know their equations, suppose we only have the table of values, so how do we know? So what we will do is, notice that there are blanks here below. It means we will find the differences to the values of y. So we will subtract -3 to -5, -1 to -3, 1 to -1, and so on. So if we do that, we have here -3 minus -5, and we have -1 minus -3. We also have 1 minus -1, and 3 minus 1, 5 minus 3, and 7 minus 5. So if you subtract this, this becomes -3 plus 5, because negative times negative is positive. So that is positive 2. So here it's 2. Next, -1 minus -3, so that is -1 plus 3. So that is 2 again. Then we have 1 plus 1, so that is 2. Okay. Then 3 minus 1 is 2. So this is 2. And 5 minus 3, that is 2. And 7 minus 5 is also 2. So here, notice that the first differences are all equal to 2. Or the first differences are all the same, which is equivalent to 2. Now let's proceed to the second equation. So the first line here, or the first blanks, are what we call the first differences. And the second blank are what we call the second differences. Okay, so we will subtract -1 to 2, -2 to -1, -1 to -2, and so on. So that becomes -1 minus 2, -2 minus -1, and -1 minus -2, 2 minus -1, 7 minus 2, and 14 minus 7. So let's subtract -1 minus 2, that is -3, and -2 plus 1, that is -1. Here we have your -1 plus 2, because negative times -2, that is +2. So that is +1. 2 plus 1, that is 3. And 7 minus 2 is 5. 14 minus 7 is 7. So this is our first differences. Notice that they are not equal. Now let's proceed to the second differences. So we have to erase this portion. Thus we have, we will subtract -1 to -3, 1 to -1, 3 to 1, and so on. So -1 minus -3, 1 minus -1, 3 minus 1, 5 minus 3, and 7 minus 5. So this becomes -1 plus 3, which is 2. And this becomes 1 plus 1, which is 2. 3 minus 1, which is 2. 5 minus 3 is 2. And 7 minus 5 is 2. So basically, the second differences are all equal to 2. So what is the conclusion then? It means that if we have a quadratic function, they would always be equal in the second differences. But if we have the linear function, since this is a linear function, the first differences, sa first differences pa lang, it will all be equal. But in the quadratic function, dun pa lang sa second differences, ito mag-equal. So that's how you will identify, given the table of values. You have to observe if dun sa second differences, they will be equal. We already know how to identify, given the table of values, if it is a quadratic function. If on the second differences, they are equal. But if it's on the first differences pa lang, they are equal, that is just a linear function. And linear function is not a quadratic function. It should be equal in their second differences. Now, how about if we are given the graph? How will we identify if it's a quadratic function? So we will graph this quadratic function here. And we will list the points first for us to easily graph it. So the points are -3 and +2. We have negative 2 and negative 1, negative 1 and negative 2, 0 and negative 1. We have 1 and 2, 2 and 7, and 3 and 14. So we have negative 3 and positive 2. So negative 3 should be found here. So negative 1, negative, negative 3. And then positive 2, we move up 1, 2. Next, negative 2, negative 1. So this is our negative 2 as our x. Then negative 1, we have to move down. Okay. Next, we have here negative 1, negative 2. So this is our negative 1. So negative 2, we have to move down. Negative 1, then negative 2. Next, we have 0 and negative 1. This is 0, then negative 1, you move down. 1 and 2, so this is our positive 1. Move up for 2. And then we have 2 and 7, these are 2. Our 7 is here. Next, 3 and 14. 3 and 14. This is our 1, 2, 3. 14 is here. Okay. So, connect the points with a U-shaped curve. So, look like that. Okay. If we will extend that, so it would look like that. We put arrow. So this is the graph for the quadratic function. G of x is equal to x squared plus 2x minus 1. So that's the graph of the function. So what do we call this graph? So this is not a line. Obviously that's not a line, but this is what we call the parabola. So the graph of the quadratic function is a parabola. So if the graph looks like this, it's obviously a quadratic function. Let's review. Given an equation, we know if it's a quadratic function if on the left side of our equation is the variable y or the f of x or any function, and on the right side the highest or the degree of that function should be 2, or the highest exponent of our variable x should be 2. So it's a quadratic function equation. So given the table of values, we know that it's a quadratic function if on the second differences, the differences will be equal. And given a graph, we know if it's a quadratic function if the graph is a parabola.